Alright, so here's your vectors quiz review. Number one just says take these four vectors here and write them in their component form. So all you do is you just find the coordinate point of each one of their endpoints, or their terminal points. So V, its endpoint is 4, 4. Okay. S, its endpoint is -5, -8. W is -5, 3. And T is 7, -8. That's all you had to do for number 2. Just figure out the coordinates of the terminal point. Now number 2 says it wants vector T minus vector W. Well, all you simply do is you take T and you subtract W from it. So this is going to be T, which is 7 minus -5. Alright, that's going to be your A. Then you're going to have -8 minus 3. So plus plus 12, -8 minus 3, -11. So T minus W equals 12, -11. That's all there is to that one. Alright, number 3. I'm going to leave number 1 up here because we're going to need those vectors for later on. Alright, number 3 says calculate the magnitudes of the following. So we want the magnitude of V. So remember, magnitude is the square root of a squared plus b squared. Formula is also at the top of the page. So the square root of 4 squared plus 4 squared, which is the square root of 16 plus 16, which is 32, which of course breaks down to 16 times 2, which breaks down to 4 times 4. So you can pull that out. So your magnitude of V is simply 4 square root of 2. Or, if you wanted it in decimal form, it would be 5.66. Alright? Now, let's do the same thing for S. The magnitude of S is going to be the square root of 5 squared plus 8 squared. Because remember, when you square, the negatives really don't make a difference. 25 plus 64, which equals the square root of 89. And the square root of 89 doesn't break down, so you can either leave it as the square root of 89, or I would take 9.43. Alright, I'll take either one of these for S, I'll take either one of these for the magnitude of V. Alright. Number 4. Direction angle of vector S. Alright, so your formula is again at the top of the page. Direction angle is simply the inverse tangent of B over A. So just plug in your numbers. The inverse tangent of B, which is -8 over -5. Plug that into your calculator, and it should come out to be rounded to the nearest degree, 58 degrees. Now, that's not the answer we want, of course, because if you go back to your quadrants, our angle is right here. Well, that 58 degrees is just from the closest x-axis down. So what we're going to have to, and we want the direction angle from starting here. So what we're going to have to do is we're going to have to add 180 to that number to get our actual direction angle. So 58, so 180 plus 58 equals 238 degrees. And that is our direction angle, 238 degrees. Alright. On the back, number 5. Number 5 wants the unit vector of S. Unit vector version of S. Remember, your unit vector, if you look at the front, it is simply your vector divided by the magnitude of your vector. So we're going to take -5, -8. We're going to divide it by its magnitude, which we already found is the square root of 89. So we're going to divide both of them by the square root of 89. So you could leave this form. You could say -5 over the square root of 89, comma -8 over the square root of 89. I would take that as the correct answer. Alright, I would take that as the correct answer. But if you don't want to leave it like that, you want to put it in decimal form, go ahead as well. here is your, there's your decimal point. Negative 0.53, comma, negative 0.85. All right, that was number 5. That was the unit vector of S. All right, the unit vector version of S. All right, now let's look at number 6. Number 6 wants V dot S. Okay, dot product. Remember, multiply the A's, multiply the B's. Add them together. I don't know why I put a vector bracket there. All right, so V times S. So we have negative 5 times 4, which is negative 20, plus negative 8 times 4, which is negative 32. So really that's gone. So this is negative 20 minus 32, negative 52. That is your dot product for number 7. I'm sorry, number 6. It's your dot product for number 6. All right, now number 7. I'm going to leave 6 up there just because I don't want to erase it. We want the angle between T and W. Well, remember, that's the cosine, inverse cosine of the dot product of your vectors. So we're going to dot T with W. Then we're going to divide by the product of their magnitudes. Alright, so that's what we got to do. So let's take care of the parentheses first. T dot W is going to be negative 35 plus, well, minus 8 times 3 is 24 over the product of their magnitudes. When you get their magnitudes, you're going to get the square root of 113 times the square root of 34. Alright. Now, just simply do this math in your calculator. Alright. When you do that math in your calculator, you'll get the inverse cosine of negative 0.952, and of course it's going to run on. I can't write the run on here, but you would want to do second answer so you can pull that whole thing into your inverse cosine. And when you do that, you are going to end up with 162.15 degrees. Now, when you're doing the angle between vectors, you don't have to worry about adding 180, subtracting 180, subtracting from 360, all that stuff. All right, because the inverse cosine of that number right here, that will give you the angle between your vectors. Because remember, it's never going to be greater than 180 degrees. All right? So, what you want to do, don't worry about adding or subtracting anything from this number once you get it. All right? So that's 6 and 7. Let's go to 8. Almost done. Number 8, we want the projection. Alright? So remember the projection, that's a weird looking J. We want the projection of S onto T. Alright? Now remember, that's the dot product divided by the dot product of T with itself. Those are the vector arrows. Because remember, it's these two vectors dotted each other, then it's the dot product of your base with itself times the vector that's the base. So times vector T. Okay? That's not a dot product here, that's actually times vector T. So, let's go ahead and do this. The projection of S onto T is dot product 7 minus 5, negative 35, plus negative 8 times negative 8, which is 64, over the dot product of T with itself, which is 49 plus 64, and all of that is going to get multiplied by 7 comma negative 8. Alright, well, it's going to get multiplied by 7 comma negative 8. When you do these parentheses in your calculator, you're going to get 0.2566. Alright, multiply that by 7 and negative 8. After you do that, your answer, so your projection of S onto T will equal 1.8 comma negative 2.05. Alright, so that's going to be your projection. Remember, just do this first. Get that number, multiply that number by each one of these. Remember, you're distributing it over. So this times 7 is 1.8. This times negative 8 is negative 2.05. All right? That's all you got to do. Number 9. Number 9 says, suppose vector P has a property that P dot P equals 55. Use this property of dot product to calculate the magnitude. Alright, so we went over this and everybody asked me why. Here's why. We have the dot product of P with itself, it equals 55. What's the magnitude of that vector? Well, if you remember, the magnitude of the vector is the same thing as the square root of the dot product of the vector with itself. So, magnitude of P, square root of 55. Yes, it's really that simple. Which, in decimal form, which you could give me if you wanted to as well, 7.42. 7.42. Remember, magnitude is simply the square root of the dot product. Alright? Number 10, it says determine whether they're orthogonal or not. Well, P is 6, 4, and Q is negative 4, 6. So, remember, if the dot product equals 0, that means they're orthogonal. So, we're going to take the dot product. 6 times negative 4, negative 24, plus 6 times 4, 24. Negative 24 plus 24, 0, so they are orthogonal. Orthogonal. Alright. That's it. That's it. That's your cruise review. Make sure you come tomorrow, ready to take the exam. You can watch this video as many times as you need to. See you tomorrow.